The worldwide search for clean, renewable energy is now focused on previously overlooked energy sources, including solar, wind, tidal, and enhanced geothermal, among many others. Thanks to modern technical advances, these new sources of energy are becoming a common, viable alternative for daily use. Their indisputable advantage is that they are operating with natural, renewable, and inexhaustible supplies, which, when converted to electricity, is without waste. These energy alternative sources cannot be placed everywhere and must be logically optimized. The photovoltaic generator, which converts solar energy to electricity, is fast becoming the widespread solution to meet this new demand. The main advantage of using photovoltaic cells is that the input energy is readily available. It's plentiful, and it's free to all. The conversion of solar energy to electricity produces zero waste. The photovoltaic generators enable end users to be completely independent from the infrastructure distribution grid and can actually sell unused accumulated power back to the city, reversing your utility bill. Their installation is also relatively simple, requiring only minimal maintenance. The biggest disadvantage is the inconsistent collection rate, which affects the output power according to the intensity and duration of sunlight hours. Another disadvantage is the installation cost, which can take time to be offset by the lower operating overhead. The use of photovoltaic generator is now quite widespread globally. It can be used connected to the municipal power grid or off-grid, known as an island system. It's most popular where conventional power sources are not accessible, too expensive, or where users are independent, ecologically minded, and focused on long-term cost reduction. Firstly, a thorough evaluation of users' needs and energy purposes must consider the options and individual conditions present. The basic yet essential condition for effective usage is plentiful direct sunlight. Naturally, the higher and longer, the better. Even though the energy yield diminishes with the seasonal distance from the equator, photovoltaic may be used anywhere between the equator and 55 degrees latitude. The solar cell is a semiconductor element capable of directly converting the energy of sunlight to electricity. The solar cells are combined to form a complete module, which is easy to install and maintain. The solar modules are fixed to a simple structure made of aluminum, which is easily manufactured and installed by any capable technician. The whole structure can be easily dismantled quickly without waste. For roofs, there are two basic types of mounting structures. One is for tilted roofs and the other is for flat roofs and is ground fixed. The solar modules are connected in a series, and the total power the array achieves is the sum total of the individual module's power. The direct current generated from the system can be stored in batteries or converted to 220-volt AC by a converter used in the standard electrical grid. The amount of generated power can be easily monitored on a connected computer or via the internet. As we stated earlier, the two basic types of photovoltaic solar systems are the grid-connected system and the off-grid island system. From a module of 160 by 80 centimeters, you can produce about 180 watts of power, which is enough power for 4 low-wattage light bulbs, a television, or to charge a laptop and mobile phone. However, to run a washing machine, we would need about 12 modules with an active surface of about 20 meters square. In order to generate an entire megawatt of power, you would need a photovoltaic plant approximately 2 hectares in area. Most of the module has an operating life of 25 years, while keeping a minimum of 80% of their initial efficiency. For the island systems, the weight of the components is very important. One module weighs approximately 14 kilograms, and the box, with inverter and batteries, weighs approximately 40 kilograms. Long-term evaluations have discovered that normal outdoor conditions, such as wind, rain, and dust, have no measurable effect on normal operation or peak output power of the solar collection system. The rate of return on initial investment depends on the local cost of power. However, the general rule is that the higher investment costs are eventually recovered due to low operational costs over the entire lifetime of the solar collection system. The use of solar voltaic systems is indeed a very promising and viable energy alternative. Economically and ecologically, energy independence and long-term cost savings are pushing solar photovoltaic systems to the forefront in the coming years.